All right, we love our shorthand again and again. If we did things as tables, then we need infinitely many things to describe this function. If we had graphs, you saw what happened before with graphs, right? I wasn't sure, is this 2.5? Is this 2.2? Is this negative 1.2? All this stuff. Well, now let's solve both problems at once. Start with example 10. Express the relationship, which may or may not be a function. Well, all right, we're telling you to express as a function in that form. What does that mean? That means I want P to be our output. I want N to be our input. So in other words, put P on the left and N on right. That's all this is really telling you to do. And everything else. So also put the numbers on the right. P needs to be by itself. There's some low-hanging fruit jokes for that. I'll let those fruits stay on the tree. Okay, so keep P on the left, move everything else to the right. So P is already on the left. Let's move the 2n over to the right. So we're going to subtract 2n from both sides. They're going to cancel. And we're going to get, when we add these things together, let's not make this too complicated. So 2n minus 2n is 0. And we have 6p left over. We have a 12, and we're subtracting a 2n. These are not like terms, so they cannot combine. So we have 6p equals 12 minus 2n. P is almost by itself, but there's a 6 in front of it. So we need to divide everything by 6. So that's going to give us now P. Now we have 12 divided by 6. That's 2. And 2 divided by 6, that's a third. We're going to get that P is 2 minus a third n. So now we have P written as a function of n, which means that if I give you an n, all you have to do is replace all the n's on the right-hand side and simplify, and we'll find out what P has to be. As opposed to this formulation, where if I gave you an n, and I wanted to know what P had to be, you'd have to solve the equation again. Plug in, simplify, and solve. But now we just did it all at once. So F, in this case, F is just the function. It's the instructions that say take 2 and subtract by 1/3 of some number. That's what F is. F is those instructions. Take the number 2, subtract a third of any number. That's the rule. That's the rule of F in this case. And it saves time because we don't have to solve. If we had to evaluate this function at 5 different places, we only have to solve it once. And now we can just plug in and simplify. If something's in that function notation, just like this, then if we want to evaluate a bunch of different things, we only don't have to do a bunch of algebra, just kind of simplifying. Evaluate k of 2. Again, 2 is our input. 2 is our t. Everywhere that there's a t, we replace with 2. K of, not multiplication, remember this is function notation. K of 2, we saw a t, we replaced it with 2. T squared, well that's now 2 squared. All the t's become 2's. Now we follow order of operations. You get that k of 2 is 10. Evaluate means we have an input, we find the output. Solve in part B is going to be the flip side. One's a little different. Okay, here's what we know. We know k of t is t cubed plus 2. We also know that k of t is 1. So if k of t is 1, we can replace k of t with 1. These are the same things. K of t equals 1. K of t is the same thing as 1. So let's replace. Here we knew t was 2. We replaced all the t's with 2. Here, in part B, we know that k of t is 1. Replace k of t with 1. And now we solve for t. We'll subtract 2 from both sides. 1 minus 2 is -1. We're left with t cubed. Take the cubed root of both sides. We're going to get that t is equal to the cubed root of -1, which is -1. And your calculator can help with this. You need to brush up on cubed roots. And you can check your answer here. It's a really good idea to check your answer. An input of -1 should be an output of +1. Right? That's what we're claiming here. We're claiming that an input of an input of -1 gives us an output of +1. So if we plug in -1 into our formula, replace all the t's with -1. -1 cubed is -1 times -1 times -1. That's -1, again, plus 2 is +1, just like we wanted. Let's get one more practice and then do a try it now to finish things off. All right. So now we have a new function we're also going to evaluate and solve. You can actually pause the video here and do this on your own too if you want. That's good practice. So again, evaluate means we know the input. We need to find the output. Replace all the p's with, again, the input's p, so replace all those p's with 4's. 4 squared plus 2 times 4. That's 16 plus 8. That's 24. When our input's 4, our output is 24. Now here, it's the opposite. It's kind of the opposite. Solving, we know our output, but we need to find our input. H of p is the same thing as 3. Instead of writing h of p here, I could just write 3 instead. Now things get a little exciting. We'll review how to do this in chapter 4, I believe. We got a quadratic equation. So there's a lot of different ways that we can do this. We can solve it by factoring. We can solve this with a quadratic formula. We can solve this by completing the square. Lots of ways of doing this. I'm going to complete the square because I love completing the square. Now let's solve it by factoring. So subtract 3 from both sides. And now, since it's equal to 0, we can now factor. We need two numbers that multiply to that -3 to add up to that middle coefficient of 2. So +3 and -1 are going to work. They add up to 2. They multiply to -3. Those are our factors. This becomes p plus 3 and p minus 1. That gives us that this is true when p plus 3 is 0, and when p minus 1 equals 0. We'll do a little bit more review on this in chapter 4. So p is going to be -3 and +1. And again, as we really get more into solving quadratics, I can provide some extra resources if this is fuzzy for you. Quadratic formula also works. All right, and that's it. Go ahead and try the try it now part, see how you do, and we can go through it together afterwards. You have 5. 5 is our input, our m, so we're going to replace all those m's with 5. Square root of 5 minus 4. 5 minus 4 is 1, and the square root of 1 is 1. And now, likewise, g of m is the square root of m minus 4, but we also know that g of m is 2. So let's replace g of m with 2. Now we need to get m by itself. We have to undo the square root. How we're going to do that is square both sides of this equation. 2 squared is 4. A square root squared, those cancel each other out. And we get m minus 4. We need m by itself. So we're going to add 4 to both sides. We get that 8 is equal to m. So g of m is equal to 2 when m is equal to 8. And again, you can check your answer over here. by saying what happens when I plug in 8 into our formula. Square root of 8 minus 4. That's the square root of 4. That's 2. Great. G of 8 equals 2. An input of 8 gives an output of 2. This is exactly what we wanted. The output is 2 when the input is 8. Let me know if you have any questions. You survived the first section. Enjoy the homework and have a good rest of your day. Bye-bye.